Picture a canyon carved from solid limestone, dropping 250 meters deep into the earth. The walls are held open against the crushing weight of a mountain by exactly 180,000 rock bolts. This is not a natural wonder. It is a desperate 32-kilometer man-made artery designed to save the global economy. Every single day, roughly 20 million barrels of oil move through a stretch of water so narrow you could practically shout across it. Vessels the size of skyscrapers are squeezed through a corridor smaller than most city commutes. But what if humanity could carve a bypass straight through the most hostile terrain on Earth? Can human engineering truly defeat ancient geography? Will a $200 billion trench actually solve the global energy crisis? Or are we simply trading one catastrophic vulnerability for another? The modern global economy does not just depend on oil. It depends entirely on oil moving. When the flow of crude stops, everything on Earth becomes instantly more expensive. The Strait of Hormuz sits perfectly positioned between Iran and Oman at the mouth of the Persian Gulf. The shipping lanes within this physical gap are a mere 2 miles wide in each direction. The record shows us, unambiguously, that this one corridor carries roughly 1/5 of all global oil consumption. It is exactly like living in a massive apartment building with only one staircase. Every tanker leaving Saudi Arabia, Iraq, Kuwait, Qatar, and the United Arab Emirates must pass through this politically contested maritime hallway. If this critical transit choke point is blocked, the world faces a severe global energy shock. This chilling reality forces strategists to obsess over a radical alternative. They envision cutting a massive canal straight through the rugged Musendam Peninsula. The map makes the solution look almost embarrassingly simple, but what is the true cost of moving a mountain? Just a few dozen miles of land separate the Persian Gulf from the wide open ocean of the Gulf of Oman. But flat maps lie to us constantly. The Musendam Peninsula is not a stretch of gentle coastal sand. It is forged from Hajar limestone, featuring jagged peaks that climb more than 2,000 meters above sea level. This rock is ancient, severely fractured, and full of hidden underground cavities. Engineers must redesign their blast sequences entirely around cave networks the size of cathedrals. Archaeological evidence suggests this terrain has remained completely indifferent to human ambition for hundreds of millions of years. Excavating this bypass requires the removal of 400 million cubic meters of solid rock. This demands a mass relocation, equivalent to 40 times the excavation required for the entire Panama Canal. How do you initiate heavy construction in vertical mountains that lack roads or basic infrastructure? The logistical reality of this mega-project borders on the realm of science fiction. Before a single ton of canal earth is excavated, workers must carve 180 kilometers of access roads out of vertical cliffs. Equipment arrives exclusively by sea and is lifted ashore by massive cranes onto temporary jetties. Machines must climb narrow ledges positioned directly above the ocean, where one wrong move means plummeting over the edge. An army of 10,000 workers requires water, food, and shelter 200 kilometers away from the nearest city. They must build a desalination plant and a dedicated power station just to keep the construction alive. The master blueprint calls for 40,000 individual, sequenced blasts spaced meticulously over 2 years. 800 vibration sensors are embedded into the mountain to strictly monitor excessive ground movement. The first production blast vaporizes 50,000 tons of mountain in a mere 8 seconds. 40 excavators simultaneously load massive dump trucks at the base of the cut. One truck departs every 30 seconds, carrying 100 tons of mountain away, running 24 hours a day. But the highest geographic peaks cannot simply be blasted from above. A tunnel boring machine must drive through the hardest limestone in Arabia, advancing only 8 meters every single day. Carving the trench is only the beginning of this titanic struggle. To navigate the dramatic elevation changes, vessels must be lifted 650 meters above sea level. The engineering design demands 3 monumental lock systems. Each lock basin is 400 meters long, large enough to fit the Eiffel Tower inside it lengthwise. The lock gates themselves are fabricated thousands of miles away in South Korea. They measure 65 meters wide and weigh an astonishing 3,000 tons each. These gates are so impossibly large that no land crane on Earth can lift them. They must be floated into position and pulled millimeter by millimeter to their final resting seats using specialized winches. A supertanker lock chamber fills completely with water in just 12 minutes. The vessel enters from the Persian Gulf, rises over the formidable mountain, and descends safely into the Arabian Sea. The estimated price tag for this artificial waterway is staggering. The total project could cost between $100 billion and $200 billion. This financial burden is roughly equivalent to constructing 20 major international airports simultaneously. Yet, even with unlimited funding, a supreme paradox remains unsolved. The Musandam Peninsula is sovereign territory governed strictly by Omani law. As of today, Oman has absolutely no official intention of turning its rugged wilderness into a global shipping trench. Furthermore, building a colossal canal does not actually eliminate the vulnerability of the supply chain. It merely relocates the geopolitical choke point. A man-made canal is inherently more fragile than the open water of a natural strait. A single grounded supertanker or a targeted explosive attack could plug the precisely engineered passage for weeks. While the exact seismic risks remain a subject of scholarly debate, a significant earthquake in the Hajar Mountains could close the route indefinitely. The global economy would spend hundreds of billions of dollars only to trade one catastrophic risk for another. The record shows us, unambiguously, that humanity remains trapped by tectonic plates that shifted millions of years ago. We possess the advanced technology to map the surface of Mars in precise detail. Yet, the most critical physical resource on Earth is still tethered directly to ancient geography. The mega-engineering Goliath exists today only as a desperate, unfulfilled dream. It stands as a monument to our undeniable, collective fear of the Strait of Hormuz.